Hello all, let's start part 2 of the section 3.2. In part 2 of this section, I will cover for you the quotient rule. How we work with the quotient rule. Look, again, if you have two given functions, one of them f of x and the other one is g of x, we are looking here for the derivative of f of x over g of x, the quotient between these two functions, or the dx of f of x over g of x. How it works, I'll write the formula for you. What we do, we write the function that's in the bottom, g of x. Then we multiply this function with the derivative of the top function or numerator, the dx of f of x. Then the sign in between, always minus. Now we keep the top, f of x, times d dx of the denominator, which is g of x, over g of x all square. This formula is a kind of long. Is it difficult? No. If you can just memorize it, maybe in English. One way that I learned, I used like kind of words that gives me a hand. I memorized it this way: bottom, d top, minus top, d bottom, over bottom square. I memorized it this way. In your book, it's written denominator times the derivative of numerator minus numerator times derivative of denominator over a square of denominator. Also, I can write this one in prime notation for you. d dx of f of x over g of x equals g f prime minus f g prime over g squared. For some students, this form becomes easy to memorize. G f prime minus f g prime over g squared. In the problems, again, I'm in favor of this. I'll use this notation because it helps you a lot where to take the derivative. I always use that notation. I liked it. But this is your formula for the quotient rule. One thing about this formula, that your denominator, which is g of x, cannot be what? 0. It should always be against 0. Because if the denominator becomes 0, then it becomes undefined. Then in this formula, we have to write that g of x cannot be 0. Now, let's start with an easy numeric example. Then we do few and we are done with section 3.2. Correct? For example number 1, they give you a function, let's say f of x equals x over 2x minus 4. How to find, and they're asking you differentiate, or they tell you to find f prime of x. It means find the first derivative of this function. To write every single step for you, f prime of x equals d dx of this quotient, which is x over 2x minus 4. And it means I follow the rule. Bottom, which is 2x minus 4, g of x. Then you see, even I'm writing these steps. d dx of the top, which is x, minus top, which is x, d dx of the bottom, which is 2x minus 4, over bottom square, 2x minus 4 squared. Again, you see the d dx notation helps you where to do the work. In the next step, you will find this derivative and you will find this derivative. Only these two things. Then it's equal to, let me go down a little bit. I'll keep 2x minus 4 times d dx of x is 1, right? Times 1 minus x times d dx of 2x minus 4 gives you 2, because the derivative of 2x is 2 and the derivative of 4 is 0, then it's times 2. Over, keep the denominator in factor form. Do not touch the denominator. Keep it this way, 2x minus 4 squared. Now simplify the top. Distribute 1. It gives you 2x minus 4. Minus 2 times x gives you 2x over 2x minus 4 squared. Positive 2x, negative 2x cancels out. Then your answer is negative 4 over 2x minus 4 squared. Final answer. Let's do another example. For example, f of x equals, let's say, x squared minus 4 over x plus 1. They are asking you to find f prime of x. Find the first derivative of this function. What I'll do here, I will write f prime of x equals d dx of x squared minus 4 over x plus 1. Now I'll apply the rule, which is equal to bottom x plus 1 d dx of the top, d dx of x squared minus 4, minus top x squared minus 4 d dx of the bottom, which is x plus 1, over bottom square x plus 1 squared. It's equal to, let's take the derivative, then x plus 1 times d dx of x squared minus 4. d dx of x squared is 2x and d dx of 4 is 0. Minus x squared minus 4 times d dx of x is 1 and d dx of 1 is 0. It means you get x squared minus 4 times 1. Over denominator squared. Do not touch the denominator. Keep it in this form. Now distribute the top and simplify. 2x times x gives you 2x squared plus 2x minus x squared. Here distribute the negative also at the same time. Minus x squared plus 4 over x plus 1 squared. Combine like terms if it's possible. 2x squared minus x squared gives you x squared plus 2x plus 4 over x plus 1 squared. Correct? That's your final answer, which is your f prime of what? F prime of x. Some of them becomes too long. They are bigger functions, and the only thing that you should do here is to go slow. Focus on everything. Do not lose the track of your work. You will be okay. Because, let me put an example. For example, even the radical is involved, right? As usual. Let's say I have a function, another example. F of x equals square root of x over x squared plus 1. What I do, if they are asking me here to find f prime of x, before touching that, I will write my radical notation to exponential notation. I will rewrite my function like this. F of x equals square root of x means x to the power of 1/2 over x squared plus 1. Now I'll take the derivative. F prime of x equals d dx of x to the power of 1/2 over x squared plus 1. Then f prime of x equals to apply the rule, apply the quotient rule. Bottom, x squared plus 1, d dx of the top, d dx of x to the power of 1/2, minus top, x to the power of 1/2, d dx of bottom, which is x squared plus 1, over x squared plus 1 squared, over bottom square. F prime of x equals 2. I'll keep x squared plus 1. d dx of x to the power of 1/2. I did it few times for you. I show it in few example. It's 1/2 x to the power of negative 1/2. Minus, I'll keep x to the power of 1/2 and take the derivative of this part. The derivative of x squared is 2x and the derivative of 1 is 0. Now what I do here, I will distribute everything. Of course, I'll keep my denominator. Let me go first write the denominator. I'll write x squared plus 1 all square. Let's distribute. F prime of x equals. One of the easy ways here, you see, because you have a negative exponent, you can send it to the denominator. You can write this way. X squared plus 1 over 2 times this one becomes x to the power of positive 1/2. Minus here, when you multiply x times 2x squared, 2x times x to the power of 1/2, it gives you 2x to the power of 3/2. You see, like this, x times x to the power of 1/2. This is x to the power of 3/2, right? All over x squared plus 1 square. You want to simplify more? You can simplify more. What you can do here, you can take a common denominator between the top and you simplify from there. F prime of x equals to x squared plus 1 over 2x to the power of 1/2 minus, you have to make the denominator the same for this. Here your denominator is 1. You have to multiply top and bottom with 2x to the power of 1/2. I will do that. 2x to the power of 1/2. And the top is 2x to the 3/2 times 2x to the power of 1/2. Now I'll simplify a little bit more. Of course, denominator stays the same, x squared plus 1 squared. F prime of x equals to denominators 1. Let me fix a little bit my notation because it's a little bit tight here. I'll put the f of x here, f prime of x. This is your main fraction bar. In the top, 2x to the power of 1/2 common denominator. Then you get x squared plus 1 minus, if you multiply these two, 2 times 2 gives you 4. Let's check. X to the power of 3/2 times x to the power of 1/2. It means it gives you x to the power of 4/2. It means it's x squared, right? 4x squared over x squared plus 1 all square. Now, we will combine the top. I will write it down here. I'll erase a little bit because if I go to the next page, I cannot copy this. Let me even make a little bit more space for me. Here, f prime of x equals x squared minus 4x squared gives you negative 3x squared. Then 1 minus 3, negative 3x squared over 2x to the power of 1/2 all over x squared plus 1 all square. What you can do here, you can multiply top and bottom with 2x to the power of 1/2. If I do that, my answer will be f prime of x equals 1 minus 3x squared over 2x to the power of 1/2 times x squared plus 1 all squared. Sorry, I'm at the end of the page, but I tried to finish this example here in this page because if I go to the next page, you cannot see the rest. That will be your final answer. The thing is, this problem was a little bit more complicated, but as long as you are not losing the track, as long as you are good with your algebra, you are good. The actual formula is not difficult. You see only this line, I applied the rule of calculus. The rest is all algebra. The rest is all algebra. As long as you are good with your algebra, you are doing good. I'll stop the lecture here. This was all about the quotient rule, and see you all in the next section, which is section 3.3, and I will cover there for you the chain rule.